Hello students, welcome at Educare. This is Vinod Bihani, and in this chemistry session we are going to see about the main periodic properties of elements. As you know how the elements are arranged in the modern periodic table, they have been arranged in the horizontal periods that called as and the vertical groups. You might have known there are 18 vertical columns corresponds to 18 groups and 17 horizontal rows, they are called as periods, while there are 4 blocks of modern periodic table, that is S block, P block, D block and A block. As you know their classification how? We will have that from different session for such classification of the elements. Today in this session we are going to see the main periodic properties of elements. Among that, the first one is atomic size and ionic size. What is mean by atomic size? It is the size of an atom, but this is its rough definition. What is the correct or more clear definition? The size of an atom, which is also called as atomic radius. It is the distance from the center of nucleus to the outermost cell, that is called as atomic size. And when the atom becomes ion, either positive ion by donating electron, that called as cation, or negative ion by acceptance of electron. So that we will deal there. Ionic size means size of cation and size of anion also. First, atomic size. How it changes or its periodic trends from left to right in any period of modern periodic table, that is left to right, atomic size decreases. This is because in the same cell electrons are added, but the nuclear charge increases in the same order. That causes the outermost cell slightly come towards the nucleus. However, in the last group, that is the inert gas 18 group, the size slightly increase due to interelectronic repulsion. Means atomic size decreases left to right, alkali metal to halogen, but for inert gases it is slightly increasing. Then what about in any group top to bottom? In any group we know number of shells increases and therefore the corresponding atomic size also increases. Now we deal with ionic size. We know there are two types of ions. Cations, they are with positive charge, anion, they are with negative charge. If we take example of sodium, when it donates electron, something like this, then it will have Na+. We know this configuration 2A to 1 for sodium, while its ion will have 2A. Can you see that one shell has been removed? Or even if not removed, in case of element that have after donating electron, but the nuclear charge, that is same and number of electrons however decreasing after donation of electron. Therefore atomic size for cation increases, means cation is with bigger size as compared to its normal atom, and anion has opposite criteria. Means if we take example of chlorine, when it accepts electron becomes Cl- ion, this anion, that is chloride ion, will have more atomic size than chlorine because of one electron added, slightly the expansion takes place of the outermost cell. Then the next topic there, to know its property called nuclear charge, that is the charge on nucleus. Charge on nucleus in any period, that is important property, nuclear charge. It is due to the number of protons. Protons get added as atomic number increases, and we know this increases the corresponding nuclear charge. Each proton supposed to have +1 charge. If you take the third period, which starts with sodium and the last two elements are there, chlorine and argon, the atomic number of sodium 11, chlorine 17, argon 18. So corresponding nuclear charge, that will be on sodium +11, that will be on chlorine +17, and that is decided by number of protons. This property important. Next called electronegativity. In a covalent bond, the capacity to attract the electron pair towards an atom is called as its electronegativity. For example, in HCl molecule, which is such essentially covalent bond, the bonding electron pair is getting shifted towards chlorine, and that causes such partial bond plus delta, plus partial ions plus delta minus delta, and this capacity of chlorine to attract electron pair towards itself in a covalently bonded molecule is called electronegativity. Remember, in the periodic table, in any period, left to right, electronegativity increases, but top to bottom, in any group, electronegativity decreases. Then we will deal with metallic and non-metallic properties. We know a metal is electropositive due to its capacity to donate electron, while a non-metal is electronegative and it has capacity to attract electron. We also know there are, out of these S, P, D and F block, metals are present in S block, in D block, in A block mostly. There are some elements which show both metallic and non-metallic properties. They are called as metalloids. Metalloids, example silicon, example germanium. Metallic property decreases in any period left to right, but metallic property increases top to bottom in any group, that is top to bottom. One more there, ionization enthalpy, that we will see here. Ionization enthalpy is the energy required to remove the most loosely bounded electron from its outermost shell, and this is very important to decide the metallic and non-metallic properties as well as in chemical reaction. Ionization enthalpy, that is, increases left to right, while ionization enthalpy decreases top to bottom. So this is about some important metallic properties and non-metallic and few other of the elements in the modern periodic table. If you have liked this video, you can have that like and share this video, as well as subscribe to our channel and press the bell icon so that you will get further notifications.